Okay, I want to do a quick lesson today on continuity. I want to give you guys a chance to work on your choice assignments. Um, if you do not have a copy of your choice assignment, you forgot it or what have you, I'll post one on the web, and if this podcast, please go to the website and show a copy of that after. If you need to work on it, feel free. That for the supply teacher. If you guys can work, if you need to work with an elbow partner, that's fine. Please struggle with this a little. The idea of the choice assignment is to help you study for your test. It will be difficult in some parts, but that will make you grow as a person and grow as a mathematician and make sure that you can ace this test. Your test will be on Wednesday. Today's lesson is on continuity. A graph is continuous if it can be drawn without lifting your pencil. Okay, why do we care? The reason that we care is that you cannot take the derivative of a function unless it's continuous. Okay, so we have to check for continuity here. For a function to be continuous, at x equals a, three things have to happen. Number one, the limit as x approaches a, f of x must exist. That means you must be able to get it to a tangible value, not like infinity or 0 over 0 or something like that. Number two, f of a is defined. Okay, let's say you have something where you say, I'm going to slow down here. Something like square roots, where if you take the square root of x, your domain is only x is greater than or equal to 0. So in that case, you can't take the derivative of the square root function for negative values of x because they don't exist. Number three, and the limit of x approaches a, f of x equals f of a. Okay, so what that means is if the limit as x approaches 3 is a number that's different than f of 3, then there's a problem. Okay, let's do a few little quick examples of graphs, and I'm going to stop, and then I'll let you guys work it. Example 1. This is a continuous graph. This is an example of a continuous graph. Okay, this is one I will draw a variation of a cubic graph right there. Okay, that was drawn entirely without lifting my pencil. Okay, there's no holes in it, there's no problems. That is a continuous graph. Example 2. Will be a graph with discontinuity. Okay, this is called an asymptote. This is f of x equals 1 over x. If you remember, this is the graph of 1 over x. Looks something like this. That is a very rough sketch. Okay, because it's a not continuous graph, does that mean that you can't take the derivative of it? Well, no, of course I can take the derivative, but the problem is I cannot take the derivative at the point x is equal to 0. Because f of 0 is undefined, it fails part 2 of my continuity test, so thus the entire graph is not continuous. Okay? I can still take the derivative on the right-hand side or the left-hand side for individual points. We have to remember the restriction, x cannot be 0. That limits the continuity. Example 3. Is the graph, which is a, this is the graph f of x equals x squared minus 9 all over x minus 3. That is, in fact, a linear graph with a hole at x equals 3. So it's going to look something like this. My mind is going blank here, sorry. That's what this graph looks like. And this is going to be the point 3, 6 is the hole. This graph is not continuous because every value does not exist. Okay, there is a problem with x equals 3. You cannot get the derivative at x equals 3. Every other point in the graph you can, except for x equals 3. Example 4 is called jump discontinuity. Jump discontinuity is something like this. What that means is the graph continues along like this, but once it gets to a certain point, it changes its value. Okay, the problem with this is that the limits on either side are not equal. All right, finally example 5, and then I'm going to stop. We'll talk more with this when we get back into derivatives again here. Okay. Is this continuous? Is that a continuous graph? It's 3 linear graphs put together. Well, the answer is yes. Okay. The potential problems are whether the slope changes, but because they have the same value, if you take a look at this point right here, they're both heading towards the same point. They're both trending towards the same point, and a point exists, so that is a continuous graph. The same thing here. It looks like something funny could be happening, but the point actually exists, so that is in fact a continuous graph. All right. All right. There we go. I'm going to throw some homework on the board. This is optional if you want to get 100% in this course. But I will not be formally checking this next week. Please do your choice assignment this week, or most of it. On Monday, I'll be going through some more difficult limits, some more difficult derivatives, and some more there's a few word problems in there. You should have enough tools right now to be able to do your choice assignment. Try it out. Good luck. Do it this weekend. If you're somebody who's just going to leave it till Tuesday and hope to get it done, good luck to you. I don't know why I'm so negative. Probably because it's late at night and I'm recording this video. Okay, thanks very much, everybody. Have an excellent weekend. Send me an email this weekend if something is not clear. Bye.